Hello, welcome. It's Science Mr. Robertson time here. Another homework. This week about mixtures. We've learned about different atoms and their structures in class and how they come together. Now we're going to see when they don't come together. Because a mixture is when I have two or more different molecules. Here's the big one. Not chemically joined together. So, for example, in my classroom, I have boys and I have girls. There's a mixture of them. They're not all joined together, holding hands all the time. At least I don't think. So, they're not chemically joined together. And there's lots of things that we have where together they're one thing, but there's lots of different things in them. The best example of this is the air we breathe. So many people seem to think the most common kind of thing in the air is oxygen. Oxygen is super important. I can even write it as O2 now we know what that means. But oxygen is only about, 21% of the air on Earth. Actually, most of the air on Earth is actually nitrogen. Nitrogen is about 78% of the air on Earth. So most of it is nitrogen, which mainly isn't very important to us, actually. It's the oxygen that is most important for us to help us produce the energy we need to live. There are some other gases too. About 1% is a gas called argon. Argon is on the far right of the periodic table, which means argon is by itself, so no 2 next to it. That's about, I'll do it down here, it's about 1%. And there's something else very important, which is CO2 and CH4. Carbon dioxide and methane, respectively. Coal dioxide, methane. There's only very little amounts of these gases in the atmosphere, but the amount of them both is going up. And these gases here are actually greenhouse gases. They actually help to make the world warmer. The point here is, though, air is a mixture of different gases, different molecules, all in one big, blanding. Another example we can have is not in air, but actually in a liquid. And it covers most of this planet. Is the camera moving? Oh, cool. I'm talking about water mixed with salt. I'm talking about salt water, saltvatten. Most of the Earth is covered in salt water. Cool. And if I put some water, here's my water, and I have a little bit of salt, I put it in, give it a good mix. The salt kind of disappears, but it doesn't. It doesn't disappear. The word I'm using for here is dissolve. På svenska, det löser upp. Och den svenska har faktiskt, det svenska ordet är bättre än den engelska. It's dissolving. It goes into the liquid and is able to stay in and around the liquid and move around with it because it's quite a small solid, the salt. So we can dissolve things in them. And this is where it actually gets really important to use those Swedish words. The Swedish words just make so much more sense. If I have the water, for example, the water is the liquid, and the liquid in this example is called a solvent. There we go. På svenska, det är lösningsmedel. Det är vad ni lös upp i. Cool. If I have the salt, Then the salt is going to be my solid thing. That's my solute. And do my salts like this here. And det är på svenska löst ämne. Det är den ämne vi löser. Makes so much more sense in the English. Finally, I then have the salt water. I combine them both together. That, of course, is my liquid plus dissolved solid. This is called my solution. So I can have, here's my water, here's my salt in it there, löst up, going around, and there, en lösning. Det betyder så mycket mer på svenska. Lots of words there. Lots of words there to know. Solvent is always a liquid. Solute, a solid. Together, they make a solution. Salt water is very simple, and it's the example I will come to most when we're using these words. But not all salt water is the same. Because I could have here, I could go put in some salt. Very nice. I could put in a bit more salt. These two are now not the same at all. What we would say here is this has a higher concentration. It is a stronger solution. Det är mer, som sagt på svenska, mer koncentrerad. If any of you have had like saft and you have to put water in it, it's the same idea. If there's more of the actual material in it, it's going to have a higher concentration. However, I can't keep doing this with my salt and water forever and ever and ever. There's a limit. There's a maximum amount of salt I can put in. When all the space is full, there's no more space. When there's no more space to dissolve, then we have a problem. It's going to be what we call saturated. They're met. There is no more space to take anything up. All the salt just falls to the bottom, för det finns ingen mer plats. There's always a limit with a solution. You can't make it 100% strong. Okay? There's the week's video. Questions below. Take care.